In this video, we will explore mean squared error, or MSE. Here is the formula for mean squared error. In this formula, n represents the total number of data points. Y_i is the actual value for the ith observation. And y hat represents the predicted value. The term squared means we square the difference between the actual and predicted values. The mean squared error measures the average squared difference between the actual values and predicted values. Now, let's look at an example with some data points. Here are some example data points, showing both the actual and predicted values, along with their squared errors. Next, we calculate the mean squared error step by step. The calculated mean squared error for this example is 0.3325. Let's take an example for MSE, using a fun darts analogy. Imagine you are playing darts. The bullseye in the center represents the perfect prediction, or the predicted value. Now, let's throw some darts to see where they land. Each dart represents the actual results. For MSE, we measure the distance from each dart to the bullseye, and then square these distances. Let's visualize how squaring distances affects the penalties. See how squaring the distance exaggerates the penalty for larger distances, showing by red dashed line. The mean squared error is the average of all these squared distances. It gives us a sense of the overall error, while emphasizing larger mistakes. If your darts are mostly close to the bullseye, the MSE will be small, indicating good predictions. MSE answers the question, how bad were my biggest misses? It's useful when larger errors need to be penalized more heavily. Let's dive into RMSE, or root mean squared error. It's a way to measure how far off our predictions are, just like MSE, but in a more intuitive scale. RMSE is simply the square root of MSE, which gives us the error in the same units as the data. Let's visualize RMSE with the same darts analogy. As we know, our MSE is 0.3325. So our RMSE is the square root of MSE, which is approximately 0.5766. Here are some key takeaways about MSE and RMSE, or mean squared error and root mean squared error. MSE measures the average squared difference between actual values and predicted values. RMSE is the square root of MSE, providing error in the same scale as the target variable. Smaller MSE or RMSE values indicate better model predictions. MSE and RMSE penalize larger errors more heavily due to the squaring operation. Now, let's discuss when you should use MSE and RMSE. First, MSE and RMSE are useful for evaluating regression models where penalizing larger errors is critical. Second, use these metrics when a balance between interpretability and sensitivity to large errors is needed. Lastly, these metrics are effective for comparing model performance across datasets with similar error scales. On the other hand, there are cases where MSE and RMSE might not be the best choices. Firstly, avoid using MSE and RMSE when outliers significantly skew the results, as squaring magnifies their impact. Secondly, these metrics are not applicable to classification problems or non-continuous targets. Finally, consider using simpler, robust metrics like MSE when interpretability is preferred. By understanding when and how to use MSE and RMSE, you can better evaluate regression models and make more informed decisions about your data analysis process. Thank you for watching, and see you in the next video.